tell me why they can't make washers the same thickness? And I mean, like, the same style of washer. Bought 20, 35 of them? Why are some of them thicker? Our engineering building has two detailed scaled models of the Gordie Howe Bridge that were generously donated to our campus. One of these sits in our main meeting room where committee meetings, faculty, and industry partner discussions take place. To add an engineering twist, I was commissioned to create miniature figures that represent key students, faculty, and industry partners. This quickly became my smallest project to date, small in size, not in complexity. Instead of hyper-realistic miniatures, I decided to use Lego-styled figures to simplify the process and keep a unified base model across all figures. True to scale people would have been extremely small with respect to the bridge model size and impractical from my skill level and print capabilities, so some creative freedom was taken going the Lego route. This approach allowed for clothing, hair, and accessories to be customized easily for each person. To get started, I sourced existing LEGO-style figure models from file-sharing sites such as Thingiverse and Printables. I started with the LEGO figure model with movable joints from Thingiverse, and after downloading it, I opened it in Fusion 360 and lengthened the legs to keep them proportional since the original model had shorter legs. I printed several test figures at the target scale to dial in ball joint tolerances, making sure that the figure stayed posable even when printed small and in filament. For the final version, I used the large tolerance model from the same Thingiverse page and scaled it down. Each figure ended up being about 1 inch tall before hair was added and before being glued to the display base. Figure parts for this project were printed with a 0.2mm nozzle at a 0.06 to 0.08mm layer height. For each model's hair, I found a set of Lego-styled hair models on printables. These were scaled to fit the printed heads. I printed them separately and glued them on, allowing for each figure to be customized. I also scaled down small chicken and dog STL files to represent the pets of some of the figures or people that I was recreating. All other accessories were modeled in Onshape and printed with the same 0.2mm nozzle and 0.06mm layer height to stay in scale and push the limits of filament printing. These accessories included hoop earrings, a camera, microphone, hockey stick, sunglasses, a cell phone, and even a flag. Everything was hand-painted using acrylic markers and acrylic paint with fine-tip brushes. A white base coat was applied to all parts to improve paint adhesion and color opacity. If I were to do this again, I'd spend more time in the slicing and printing stage to create multicolor prints using different filament colors for the pants, shirt, and skin of the Lego figures. Painting each figure ended up being the most time-consuming part of the project. A huge thank you to Miriam, Jade, and Bruna for helping me with the miniature painting. The next challenge of this project was placing the figures on the bridge model. Since the model is delicate, one of a kind, and donated, the main constraint was that nothing could permanently modify or damage it. Adhesives directly on the bridge model were not an option. I would like to share this little mechanism thing that I made. I made a bunch of these super tiny Lego figurines. I printed these Lego plates and the final ones are in white. I'm really happy with the kind of joining mechanism that I created. So first there's a washer in the center that's to add some weight to the little Lego piece. There will be one brick like this on each piece to have a name tag for the figure, and then the figure will be glued. Then to join more than one of these Lego plates together, I created these links. Different plates can snap together and hold each other in place. And then to make sure this link is held in place and to cover the washer so the surface of the model doesn't get damaged, I actually have this cork tape. I'm just going to cut a little square for each of the plates, and I size the plates to exactly fit the width of the tape. So the final result on the bottom looks something like this. Not only does the washer add weight, but the cork adds a nice slipless kind of surface on the bottom similar to a coaster. And so that is my solution to adding the Lego figures to the model without damaging the model itself. My desk is a little bit of a hot mess. We have all the little figures that need minor touch-ups on here, paint markers, some of the prototypes of this draining mechanism I just showed you. I need to fit all of the name tags. They just need to be slightly heated with the hot air gun and fit directly onto the plate so that they're easier to super glue, because the fitment that I created is just a little bit too tight and I don't want to waste all of these. So that's what I'll be doing. Tomorrow is the event that I need these figures and stands done for. Just headed to the school to kind of double check the bridge model and the sizing of what I've done so far, and I think I'm gonna change it. You probably saw earlier how I have this mechanism, excuse the markings, those are just my changes. How I have this like joining mechanism, this is the base plate with a washer for added weight. I'm going to put cork over it, and then I made these links to join plates next to each other. Looking at how big the model is, it's like several meters long, like a meter wide. I think it's honestly better to just make each figure have its own smaller base, so I won't need any of these linking features anymore. So what I will do is change the size of the plate to be about this big within this red square and get rid of these underlocking features and just have each plate go on its own. So we're gonna head to the hardware store and buy 20-ish more washers to have enough for each figure, and then remake the CAD models and hit print. I think this design change will be worth it. After some overcomplicated earlier prototypes, I settled on a simple Lego plate base. A cutout on the underside holds a thick washer to add weight and keep the figure stable once it's placed on the model. A layer of cork on the bottom also created a smooth, non-slip surface where the base contacts the bridge model. Each base also had a Lego brick attached where I used my label maker to create name tags for each figure. The Lego brick and Lego plate base were printed with 0.4mm nozzles at a typical 0.2mm layer height. As per usual, I was in a time crunch, so I don't have too much footage of me wrapping up this project, but after gluing all the figures onto the base plates, I spray painted everything with a few coats of this quick dry clear coat. Then I added all the name tags and promptly drove to school for the unveiling event. Everyone loved their figures and they're happily still sitting on the bridge model. In total, I made 32 figures, 31 people, and one miniature dog, Winnie. She is our Faculty of Engineering therapy dog. By far, this is my smallest project yet, and I'm quite happy with how each of these figures turned out. I definitely think this is a one-of-a-kind project that will sit in our Faculty of Engineering building for years to come.